Intermediate Value Theorem explained. Let's look at this yellow curve. It represents the graph of a continuous function. Let's start with a point on the horizontal axis, a. When we evaluate the function at this point, we obtain its corresponding value on the vertical axis, f of a. Now, let's take another point, b. Its value on the curve is f of b. Notice that f of a and f of b are different. The intermediate value theorem tells us something powerful about what happens between them. Take any value y that lies strictly between f of a and f of b. Since the function is continuous, its graph cannot have jumps or breaks. It must pass through all intermediate heights as it goes from a to b. This means that inevitably, at some point between a and b, the curve will reach exactly that height y we chose. That intersection point we'll call c. And, by definition, the value of the function at c is precisely our y. Therefore, y equals f of c. Let's apply the theorem with a concrete example. Let's use the function f of x equals x squared over 12 plus 1. We define a equal to 3 and b equal to 9. We evaluate f of 3 gives us a value which we call f of a. F of 9 gives us a larger value which we call f of b. On the graph, we see their corresponding heights on the y-axis. Now, we choose an intermediate value between f of a and f of b. Let's take y equal to 4. The intermediate value theorem assures us that there exists a c between 3 and 9 such that f of c equals 4. This translates to the equation 4 equals c squared over 12 plus 1. When we solve the equation, we obtained that c equals 6. We verify c equals 6 is within our interval. Save this for your next study session.